Okay, Team A level. So I want to do a few recaps on some of the stuff that we've done already, just sort of to clarify some bits, and before we start some year 2 content. So some of the stuff I want to look at today is around biomechanical principles, and more importantly Newton's laws. All right, and this is probably one of our stronger areas. All right, it's the stuff we've done so far. But again, I just wanted to make sure that we had absolute clarity on what they were and how to apply them. Okay, so a couple of videos to put in, as well as some key definitions. Okay, so hopefully this will work. Okay, so Newton's first law then, all right, is his law of inertia. All right, and what this law states is that every body or a body at rest or a body moving will want to stay at a constant velocity unless acted upon by an external force. Okay, so in terms of our golf ball there, it will stay as it is. All right, it will stay at rest. All right, or it will stay at a constant velocity in the same direction unless it is acted upon by an external force. Okay, as we can see there, the sort of the gravity and the equilibrium of the tee holding the ball up will mean that that ball will stay where it is. If there were an external force to act upon that ball, okay, whether that be a golf club, whether that be wind, okay, then it would move, all right, and it would continue in that state of inertia, i.e., it would keep moving unless it was acted upon again by another external force. All right, so to put that into a little bit of perspective, again, I'm hoping this works. He says, so hopefully. Okay, so again, in that situation, in terms of our golf swing, the ball moving by the force of the club hitting it is an unbalanced force, which would change the state of inertia. It would overcome the state of inertia of that body at rest. Now, in terms of when that ball is hit, that ball would obviously continue on that path, all right, unless it was acted upon by an external force. And again, those external forces generally are things like gravity, air resistance, friction. All right, so it's being aware of how these laws interact. All right, and again, we can sort of relate that to any sort of example. So, for example, an individual will stay at rest unless it is acted upon by an external force, all right, or provided an external force. So, any sort of muscle contraction can cause a body, a human, an athlete, all right, to overcome their state of inertia at rest. Okay, so just be mindful, of that, sort of as we go through. Okay, so Newton's second law then. Okay, so his second law is the law of acceleration, all right, which effectively states that the rate of change of momentum of a body or of an object, all right, is proportional to the force causing it, all right, and takes place in the direction in which the force acts. So in that sense, then, all right. So to put it simply, all right. The rate of change of momentum, so the acceleration of an object. So if we've got a footballer kicking the ball here, the ball will accelerate, all right, in a straight excuse me, in the straight line or in the direction the ball is kicked, at a greater force if it is, if it is kicked harder. Okay, so the more force that the footballer applies, all right, through his backswing and through his contact of the ball, the quicker that ball is going to accelerate. All right, much like anything. All right, if, for example, a tennis player, if a tennis player applies more force through the racket onto the ball, that ball is going to accelerate in the direction it's hit at a much faster rate. All right, so the greater the force that is applied, okay, the greater the acceleration of that object. All right, and you can sort of talk about it then how that makes the object harder, for example, to return. But again, any sort of sporting example where the greater the force that is applied, okay, the greater the acceleration of that object. All right, you can link that to many different sporting examples. So in terms of just putting that into a little bit of context, if we watch our, it's going to work. Okay, so just to add a little bit of clarity sort of around this here. Okay, so if we have the same force, okay, so again, acceleration or the change in momentum directly proportional to the force that is applied. If we have a force that is acting upon a small mass, okay, that will lead to what they determine to be a where is it to play it through? Okay, a large acceleration there. All right, so the same force then applied to, so exactly the same force that is applied to a larger mass. Okay, so if we imagine a golf ball, a golf club hitting a golf ball, all right, at a certain force. If we then hit the bowling ball, the acceleration would be a lot smaller. Okay, so in terms of this here, the rate of change of momentum is proportional to the force causing it and takes place in the direction. So if I were, again, if we think about different sports, if I were going to kick a ball, that could be a football, that could be a rugby ball. All right, we can even relate that again to sort of to our tennis swing. The rate of change in momentum is proportional to the force causing it. So the greater the force that is applied, all right, by the athlete through the racket, the faster that ball is going to accelerate, and it will do in the direction in which the force acts. Okay, so Newton's law of action-reaction. So for every force that is exerted by one body, there is an equal and opposite force exerted by the second on the first. All right, and we can sort of illustrate that here. So where she is applying force against the wall is applying equal and opposite force back to her, all right, which enables her then to accelerate off the wall. Now, in terms of where that to illustrate that without golf, hopefully it works. Here we go. Okay, so again, this concept of change in momentum of Newton's third law, okay, can be applied here, but also can be applied to your tennis swing. So in exactly the same principle. What I want you guys to have a look at for me, all right, is this question. So based on our pre-understanding, all right, and some of the stuff that we've gone through today with the videos, so you can play them back to add a bit more clarity. All right, is I want you to have a go at this question. All right, so it's an 8 marker. I want you to do this over Easter for me. All right. So a bit of context. Andy Murray, all right, in Wimbledon. But the question is asking, using Newton's laws of motion, explain how a player moves towards a ball during a rally. All right. So it's an 8 marker. So again, when you're doing your 8 marker, I want you to highlight for me, please, before you send it to me, where you get your AO1, where you get your AO2, and where your AO3 is. All right. And remember, you can use the blocked approach if you want to, or you can use the step ladder approach, depending on how you feel you best answer these questions. Okay. But plan it out first, all right, and give it a go. But again, I want you to highlight. This can be typed up; it doesn't have to be written. Okay, so you can type this up and send it to me. All right, that's probably better to do. Highlighting perhaps different colours where your AO1, 2, and 3 are, and send that through to me. All right, by the end of Easter. All right, thank you guys.